Okay, hey everybody, welcome to the June edition of Westwatch. I'm Joe Casola, who will be playing host and also my best imitation of Dan McAvoy today to give some of the kind of terrestrial conditions and impacts update. So what is Westwatch? It is a monthly webinar series that brings together NOAA staff and our partners from across the region to share information about climate observations and impacts across the West. We have two formats. Sometimes every other month we do a panel on a specific topic, and then the other months, the on months, we do kind of a general overview of climate, and that's what today's webinar will be. I'll be speaking for kind of the terrestrial side. I'm the Western Region Climate Services Director at NOAA. We're also really honored to have with us Roxanne Carini from NANOOS up in Seattle, Henry Ruhl from CeNCOOS in Moss Landing, California, and then Clarissa and Jim Behrens will be talking tag teaming from SCCOOS as well as from the CDIP update. I'll ask a quick poll question and let me launch that right now. Hopefully it's popping up to ask about your kind of past attendance at Westwatches. Thanks for filling that out. Was that? Let's try to get back to the webinar. So I think I didn't show our answers long enough, but it looked like almost half of the folks have attended previously, but almost a third, this is their first time, and about 20% are kind of regulars here. So welcome back to those who've been here before, and if it's your first time, we hope that you'll become a regular soon as well. Each of our speakers will cover kind of 10 to 15-ish minutes. Questions can be entered at any time in the question box at right. We'll try to do Q&A after each speaker, and then again at the end, if we have a little more time. Our session will be recorded. We're getting a little better at posting. We're still haven't posted May, but we've got everything else from 2024 up on the Westwatch website. And we also have a post-webinar survey that's really helpful for us. We appreciate your feedback and your ideas for new topics. So with that, I will launch into kind of the update of what we've seen temperature and precipitation wise, as well as hydrology in the last few months out west. So the kind of top level summary, March, April, May was kind of boring, close to normal for most of the West. The last 2 weeks, we really kind of had an arrival of summer very quickly, especially in the Southwest and the Great Basin, but it's been cool and wet in the Pacific Northwest. We're right now in that transition between an El Nino event and a La Nina event, so technically we're in neutral conditions, but we are expected to make the transition to La Nina in the coming months. Our summer outlook suggests that we'll have kind of a persistence of drought in some of the areas that have been suffering from drought, and we'll have an emergence, kind of an extension of some of those areas as we expect temperatures, I think largely driven by warm temperatures in the region. So here's that look at temperature and precipitation in March, April, and May. And at left is the temperature picture, at right is the precip picture. The temperature units are degrees, so it's the size of the anomaly. And the precip units are percentile relative to about the last 40-ish years. And you can see that we actually, if anything, more blues and reds across a lot of the region, so kind of on the cooler side. But many of those anomalies are not startlingly large. And as far as precip, you see kind of dryish conditions in the Northwest, and you see some kind of rainfall, kind of a blob of wetter than median conditions in Arizona, as well as in eastern Montana. But again, a lot of the deviations from kind of median or normal are not startling. Just looking at the last 30 days, though, And a lot of these anomalies are actually dominated by the last 2 weeks. You see a bit of a flip, and we see this anomalous warm temperatures kind of in the Great Basin, as well as non-coastal California and the Southwest, and relatively cool temperatures in the Columbia River Basin. We see dry conditions in a lot of the Great Basin as well as the Southwest, and we actually have had a decent amount of rainfall in the Northwest where we had been dry for most of the spring. Our drought conditions, at least depicted by the drought monitor, are shown here, and about 15% of the region, the whole West, is in some version of drought, but most of that is actually D1, is in kind of the moderate drought, the lowest of the drought categories. We have very small pockets of more severe drought, mostly in the northern Rockies and in southern New Mexico and eastern New Mexico. This relative to 2022 and 2023 is kind of an amazing picture as far as the paucity of drought in large swaths of the West. And just to compare this pattern that we have presently with where we started the water year, you can see that many of the same regions are kind of dealing with drought. We actually had some improvement in the wintertime in Oregon and in parts of the Northwest, as well as in Arizona. But in general, the places that are experiencing drought now also came into the water year experiencing drought. I wanted to just kind of recap the snow story, which I think is really meaningful for the Pacific Northwest. At left is the amount of snow of water equivalent in the snow, the SCCOOS, the snow water equivalent when snowpack reached peak at the SNOTEL stations. And you can see most of the hot colors are in the Cascades as well as the Northern Rockies, where they basically were well below their peak values. Some cases less than 50% of peak SCCOOS. So this is, I think, driving not only some contributing to the current drought conditions, but why we would expect drought to be persistent in these areas. And then by contrast, you can see in the Sierras, as well as kind of Nevada, Utah, Colorado, we had a pretty decent snowpack situation this winter, and peak SCCOOS was either around 100%, if not higher. At right is an image of the NRCS's stream flow forecast for the summer, so for the June and July period. And it really reflects the same kind of pattern that we see with the peak SCCOOS, that we would expect to be below the median stream flow volume in the northern tier and in many of the other locations. Sierras are actually not pictured here, but many of the other locations where we're either at median or above. Getting into our outlooks, this is the 8 to 14 day outlook, just to kind of show that for the latter half of June, we would expect the pattern that we've seen in the beginning of June to largely be in place. We have mostly or elevated chances of above normal temperatures for a lot of the region, with the exception of the Pacific Northwest. And you can see this kind of tilting of the odds for drier conditions in kind of the Great Basin area, the kind of Intermountain area, with a slight tilt for rainfall in the Northwest. It's also perhaps good to see some of the above average odds for rainfall in the Southwest, as there's been quite a bit of fire activity in New Mexico in particular. Looking to the June outlook, I think this is a good teaching moment for the take the conditions with a grain of salt. This was issued back in May 31st, so we're kind of mostly through June. However, I want to point out that the equal chances in the East, even though I know that's not the West, is coincident with areas that we're really concerned about for extreme heat this upcoming few days and probably to the end of the month. Not to say that this monthly forecast is a bad product, but we just have to make sure we understand what it's showing. And it's showing kind of a shift in the odds. It doesn't really tell us about particular hazards that may emerge within the course of the month. And you can see that precip outlook we had this kind of a similar pattern for what we had the beginning of the month and what we expect for the end of the month. A slight shift to kind of the dry area or the probability calling for dryish conditions into the Northern Rockies rather than the Great Basin. For the rest of the summer, the June, July, August outlook, the odds are tilted for above normal temperatures, which is very common. It's very hard to kind of beat the temperature trend, and so it's quite often that these maps are dominated by the red. You can see and to the right the precip outlook calling for dryish conditions, kind of in a long band through a lot of the west, and this really plays into some of the drought outlook. And that's what this map shows. Again, the yellow areas are where drought might emerge, the brown areas where we would expect drought to be persistent. And you can see that a lot of the brown, we don't expect a lot of improvement in the drought areas we see now as well, and we do expect a bit of an expansion in the northwest and the southwest. Also wanted to show the fire outlooks, and each of these maps is for a different month. For June, July, and August. The green areas indicate where we might expect below average fire activity, the red above average, busier fire conditions. The white means around normal, so you can still have fire, especially in a lot of the west. You can see kind of the areas in British Columbia as well as California as being in green in June. But we see kind of red in the southwest and for a lot of Canada. And in Canada, we've had many areas, especially in the northwestern Canada, where we've actually had holdover fires since fire season 2023, where smoldering continued throughout the winter, and those fires are starting to pick back up. I decided to show the North American version just because we're often dealing, as we were last year, with Canadian smoke. And I think that the July and August maps indicate we may have that situation once again. You can see the kind of drought areas popping up in July and August in the southwest, as well as where we recently had kind of dry conditions. You know, the Great Basin fires tend to be, there's a lot of rangelands, and so it doesn't, I think, take a lot when you've had a little bit of moisture, which we did have last winter. You promote growth and you have a lot of fuels that dry out later in the summer. I do want to indicate again, with any seasonal outlook, we need to kind of take things with a grain of salt. It doesn't always guide us about particular events. You may have seen in the news, the upper picture is from the Park Fire, which is, I think I got the name right, in northeastern Los Angeles County, as well as in New Mexico and kind of eastern New Mexico near Ruidoso. There's actually a couple fires that are converging right now. So these are the events that are kind of getting a lot of media attention as kind of the early large events out west. So very quickly, I just wanted to end with some notes on that ENSO transition. These are the sea surface temperatures for about the last 30 days. And you can see this kind of cold tongue in the eastern tropical Pacific, just off South America, our kind of telltale La Nina signal starting to emerge. And here are the probabilities of La Nina neutral and El Nino conditions for the next few months. Along the bottom are 3-month averages, so MJJ is May, June, July, JJ is June, July, August, and kind of so forth. And you can see we're in neutral right now, and the chances of the La Nina conditions kind of emerge as we start to get into the fall and the winter. So the forecasts have been pretty consistent, calling for La Nina conditions to prevail as we get into the fall and winter. Okay, that ends things for my portion. I'm going to turn things over to Roxanne. So let me switch the sharing to her. And if folks have questions, you can pop them into the chat or to the questions box, and I will try to field them in the next go round. Here we go. Take it away.
Can you see everything? Yeah,
it looks great.
Okay, great. Thank you. Thanks, Joe. Hi, everyone. Yes, I'm Roxanne Carini. I am the Deputy Director of NANOOS, and I'm giving the presentation on behalf of NANOOS and Jan Newton, who is on the line, though on a road trip and available for questions later. And I'll mostly be focusing on Washington and Oregon, though you'll be able to see some of the full West Coast in the slides. Here I'm showing from our NANOOS NVS platform, our climatology app, the NCEI optimum interpolated sea surface temperature anomaly from a 30-year climatology created from 1983 to 2012. So this is pre-blob, the blob years. And as I march through from March to April to May, you'll see the El Nino signal fading, which we know, but also see this heat building up in the North Pacific. And in fact, if we check the marine heat wave tracker, which identifies areas where the sea surface temperature exceeds 2 standard deviations for at least 5 consecutive days, there are some moderate and strong regions of warm anomaly that qualify as a marine heat wave. There's nothing really close to our coast. The marine heat wave is, looking at that scale bar, maybe about 300 miles or a little bit more than that off the coast. If we take a closer look at our coastal region, this is a sea surface temperature anomaly from an OSU MODIS product. It's only a 10-year climatology from 2002 to 2012, but we wanted to maintain a baseline that was akin to the others so that the marine heat wave period isn't included in this one. And we can see some warmer temperatures off our coast, warmer than average temperatures off our coast in March. Less so in April, and even less so, more things that are kind of looking pretty normal in May. This is the NDBC Washington buoy, about 300 nautical miles offshore, circled on the map on the left. And I'm showing the seasonal mean and standard deviation curves created from about 45 years of data. The conditions are hovering around average for March through May and into June, with some periods of warmer than average waters, mostly staying within the 1 standard deviation, those pink lines around the mean. Recent temperatures into June are a little closer to 1 standard deviation, and we don't know if that kind of warming trend will continue or not, but this buoy is that like 300 nautical miles offshore, so it is closer to where those marine heat waves are classified. So we might see that signal here in the future. Here are 4 other buoys, all closer to shore. They're circled and color-coded on the map, and with the dots at the top of each plot. The seasonal mean curves were created from the available record, and that varies by buoy, but it's noted at the title of the plots. And all of these coastal buoys are showing more temperature variability than the offshore buoy. They've got excursions above and below the mean. There's no major trends to point out here. The NANOOS climatology app also shows NDBC and CDIP wave climatologies compared to the current time series. And so this is the NDBC buoy, but I'm showing wave height now. Without any kind of further in-depth wave analysis, it looks like the wave conditions are starting to settle a little bit as they do into the summer months. When we progress from March into April and May. And then in early June, we are seeing the influence of the atmospheric river we experienced, which was really stormy and kind of out of the norm conditions for this time of year. Pretty strong signal there. Excuse me. And now we'll take a dip into Puget Sound and look at some of our profiling moorings, the orca moorings within Puget Sound. And so I'm showing here the Hoodsport, Point Wells, Tuano, and Carr Inlet, which are all circled and labeled with their abbreviations around Puget Sound in the map at the bottom. This is temperature anomalies, and we can see that everything is pretty red, so it's warmer than average. And in some cases, you can see the influence of that atmospheric river as cooler surface waters in the beginning of June. Now we'll look at salinity anomalies, and so this is a 14-year climatology at those same locations, and what we're seeing is saltier than average. That early June atmospheric river that definitely we could see in the temperature anomalies not showing up in the salinity anomaly is quite so much or at all. And as Joe said, we've been in a drought in the Pacific Northwest, so these saltier than average waters make sense in terms of less rain, less river runoff. Switching to dissolved oxygen. So these are the same locations except one less. And each kind of part of Puget Sound has different signatures. We're seeing both positive and negative dissolved oxygen anomalies, and they're quite variable. Here are some insets of the actual dissolved oxygen values in milligrams per liter. And so even though we're seeing some negative anomalies, we are not reaching the hypoxic conditions, which on the insets, that color would change into purple. Imagine if you don't have any oxygen, your lips turn purple. We're not seeing any hypoxic values in these locations in Puget Sound, which is great. Switching to chlorophyll anomalies. So these are satellite products of chlorophyll anomaly. They show mostly lower than average. Monthly, it's ocean color as a proxy for chlorophyll. Values March through May, though we have some blooms on the Olympic Peninsula and off the Columbia River in April, as well as down in California, but I'll leave it to Henry to talk about that. But what is important is that in Oregon, we have an unprecedented event with now at least 30 people sick and some in the hospital from paralytic shellfish poisoning in shellfish from the recreational harvest. Which of course argues for better monitoring. All of the OOSs participate in harmful algal bloom monitoring. And what's also important to note is that neither the chlorophyll satellite products nor the domoic acid levels that we were testing were high. And so it's showing the independence of different types of blooms and the need to track species and toxin level, because this was paralytic shellfish poisoning that is getting these folks. And it wasn't showing up in any of the other signals that we look for. To summarize, the coastal conditions, El Nino is continuing to weaken. There's heat building in the North Pacific with a marine heat wave classified, which is pretty well offshore. The offshore NDBC Washington buoy shows average temperature possibly starting to warm, about a standard deviation above average. And the inshore buoys are highly variable, which is usually what we see for those coastal buoys, both above and below average. Waves are pretty average, though we did see that atmospheric river and the storm associated with it. In Puget Sound, temperature and salinity anomalies continue to be warm and salty, with some cooler temperature anomalies at the surface. The oxygen anomalies are quite variable, but again, no hypoxia, which is good. And then chlorophyll and HABs, like I just said, the satellite is showing lower than average monthly ocean color values, with some blooms in April. And late May, early June, there was this unprecedented paralytic shellfish poisoning event in Oregon coast, and with closures of the shellfish harvesting beaches. And domoic acid has been present, but relatively low. And with that, I conclude. Thank you.
Thanks, Roxanne. Still no questions, but I invite folks to pop those in. I'm going to pull up Henry's slides.
Thank you. Go ahead and go to the next one there. So I'm with the Central and Northern California Ocean Observing System, Henry Ruhl. And so in the north of our region, so offshore the Humboldt area, we've been getting reports of a large bloom happening there. It's a little bit challenging to piece together from some of the satellite imagery with cloud cover and things, but what we're showing here is output from our California harmful algal bloom risk mapping system model that Clarissa Anderson helps support and run. And so this is an image from the 17th, and right around the Eureka area, you're seeing near 100% likelihood of harmful algal bloom toxin. And what we've seen from the samples so far is just a preliminary look that it's Skeletonema diatom, so it's not necessarily the Pseudonychia dominated bloom, and nor is there a high toxin of domoic acid detected in what we've seen so far, but it's still, this is just like information that's about some of it only a day old, some of it a week old. And so what we're looking at is to go, the team in Eureka with Eric Bjorkstead and some of our other CeNCOOS investigators will be going back out to look at that as early as tomorrow, see if it transitions into a harmful algal bloom or perhaps is it producing different toxin, and then also to look for potential development of hypoxia to include at the seabed. And so we know in Oregon that this can happen regularly now, and hypoxia at the seabed can impact crab fishery, among other things. And so next slide, please. Also in the region, there's been quite a lot of news about white sharks. There's a area in the Santa Cruz area in the top northeast corner of the Monterey Bay where they have been congregating lately being like the last decade or so, more and more. And this year seems to be a peak in that, but it's a little bit subjective. But there's a lot of conversation happening about it, which is exciting. You know, sharks are wild animals in a wild place, and many people are just are still digesting how to think about that as a reality. The threat from the sharks hasn't really materialized in terms of knocking on wood that there hasn't been a related increase in incidents with them, and they are getting regularly very close to swimmers, amongst them even sometimes. And but these tend to be juveniles, and they tend to be warming themselves up when they're in these waters, not necessarily feeding. And let's maybe hope it stays that way. There has been some discussion about, like, is this related to climate change? Is this related to other variations in warming patterns along the coast? And there could be some truth to that, but I think in particular with climate change, the story is still unfolding in a quantitative sense. But there also has been news about sea lion pup mortality, so that we've had reported as many as 200 or more sea lions, for example, mortality event in the Ano Nuevo Island in the central coast here. And then the reason for this is still unclear. It could be related to a lack of food or perhaps related to some specific disease that has been so far not diagnosed. And so there's several of the marine mammal centers along the coast from SeaWorld all the way in San Diego, all the way to up here in Sausalito and beyond, are looking into what's happening here, but still nothing definitive yet. And similarly, there have been lots of reports of pelican mortality, and this may have to do with the El Nino, as well as with the sea lions. Could be related to El Nino decreasing food availability, changing water conditions. In the case of the pelicans, some folks are suggesting it could be related to water clarity or visibility in relation to weather and other things, but there's not a smoking gun, if you like. So next slide. So wanted to note for ourselves in CeNCOOS and also for the Southern California Ocean Observing System that we're celebrating our 20-year anniversary of becoming established, and we had a wonderful meeting last month in May held in San Diego to celebrate that, along with the 75th anniversary of the California Cooperative Fisheries Investigations. And so Cal Coffee was really formative in how we conduct ocean observing on the West Coast and indeed globally. And so that we're thankful to our sponsors, and we're over nearly 500 attendees, over half of which were in person. And so that was an exciting event, digging into our various forms of impact in the ocean observing community for society. Next slide. So going through some of our kind of usual reporting here, a few modifications along the way. So I think not surprisingly, we're seeing the transition in these buoy stations from El Nino conditions in the winter to sort of nominal conditions now, maybe even framing into La Nina before too long in the coming months. And so we have stations going from Eel River to Monterey Bay in the center, and then Santa Maria down south from where I'm at in Moss Landing, showing similar things. And the center panel is, of course, looks very different. And what you're seeing there is not just an anomaly of temperature, but rather a depth profile, so that the y-axis there is depth down to 300 meters from the surface, and then x-axis is time for the past 180 days, as is with the others. And what you see is this reduction in the warmer temperatures at the surface and cooler water from the depths coming closer to the surface. And what that has to do with, in part, is very likely changes in the El Nino condition, but also the transition into the upwelling season here. And so cooler water is getting closer to the surface. Next slide. And so these are stations that are at the shore. And so this is the top being Trinidad Head Pier in the Humboldt-Eureka area. China Camp inside the San Francisco Bay, so northern San Francisco Bay. This is a National Estuarine Research Reserve sensor station. And then the Moss Landing Marine Lab seawater intake. So here in the Monterey Bay, from about 30 meters depth, all showing very similar patterns of transition from generally warmer to cooler conditions, although it's a bit nominal in the China Camp. Appreciating also that it's in San Francisco Bay is a little bit different than along the coast. And next slide. So for our glider observations, we have 3 glider lines running in the central Northern California region. As a reminder, these gliders, they're about almost 6 feet long, and they kind of sail through the water, making profiles of ocean conditions along the way. And so there's a little map view in the center of the panel there of the extent offshore that the glider can reach. And then there's some visualization tools that we have in our ocean data portal systems with a link there, data.caloos.org, where you can go and visualize this data. And this is the last complete ocean section from the May-June period. The sections usually take about a couple weeks, depending on conditions. And if you go to the next slide. So digging into the Monterey Bay line a little bit more, we have March, April, and May across the top there. And so what you see is the temperature conditions, and those circles there just are a reminder that the values on the axes are different. But what we can see going from March, April, May is that a little bit like I was describing for the Monterey Bay buoy, is that kind of a transition from spring into summertime conditions with upwelling happening, and also perhaps relations to changing El Nino conditions. And so if from March to May, you'll see along the coast, which is so that as a reminder, the coast is on the right side of each of those panels, and then the left side is the furthest extent offshore. And that what you'll see is cooler waters from deeper down are kind of making their way up to the surface. So we go from March, April, and May. And then along the bottom is the anomaly of temperature. And you can see there also that it's generally pretty consistently warm in March, above average, above nominal conditions. And then that transitions to having cooler deep water make its way to the surface by May and happening now as well. So that's kind of classical oceanography in some ways. Next slide, please. And so here we have a plot of ocean heat. So the anomaly of temperature on that green line running from all the way from 2007 to present, and then the oceanic heat index and the black line there, the Nino index rather. And so the conditions from the El Nino just passed, kind of among the higher of the second highest, I guess it's fair to say. The only other peak being around the 15 to 16 El Nino. And then on the right side, you'll see a similar time period covering from 2007 to 25, but vertically now. And then the right side of that panel is the shore, and then the left side of that x-axis is the distance offshore, is the oceanic extent. And you can see there also the warmer period starting around 2015 up to about 2020. And then at the very top, you'll see the El Nino, the above average warming conditions are starting to ease a bit for the Monterey line. And if we go to the next slide, we're working on developing similar graphics for our Trinidad Head and Point Arena area, Bodega Bay area lines. But these are not quite as developed and don't have the same reference period, meaning we only have data from 2015 and then for the Trinidad Head in 2020 for the line 57 there, and the anomaly is generated in part through examining other data sets where we can get some comparison of temperature. And here too, we see that just in the most recent outputs that the conditions are shifting back to nominal from, in the case of the line 57 was warmer considerably in recent 6 months, but is now shifting mostly to nominal conditions. So next slide. So here's a couple of indicators for ocean temperature as well. So we have the so-called blob tracker on the left side and a couple of instances of it, but basically we can, similar to what Roxanne had presented, there's some warm conditions outside of the EEZ of the United States, but generally along the coast, pretty nominal in our own sort of in-house marine heat wave tracker that uses the same kind of system as the system that Roxanne had showed, but just this one is model based and it uses a 3-day forecast. You can see the forecast period just now, but also showing really no substantial heat wave conditions. And next slide. In the last, let's say, few weeks, we've seen an increase in upwelling. So this is, again, could be a combination of moving into the upwelling season as well as moving into, or rather out of the El Nino condition and into more nominal conditions. And you can see that on the top panels by the greater instances of red in the last 2 weeks of May. And the longer periods are shown in the bottom 2 panels. So going back several years in the bottom 2 panels. And the QD, the one in the sort of center, and is basically transport, coastal upwelling transport, and the one on the right side is biologically effective upwelling, which is basically related to the amount of nutrients that are come along with that transport, vertical transport of water from deeper depths to the surface. And next slide. So winding up here. So this is our, we presented this in the past, multivariate ocean climate index, and it's a digestion of several different kinds of data from stations through to basin scale climate indicators. And the data that's shown there, the last 2 points on that graph for 2024, the last point is for the July, February, March. There's not yet a April, May, June instance yet, but we can expect that will probably be coming back in towards the center of the index based on other information. So this is Northern California, and then one more slide. Also, this is now Central California. The arrow is not in the right spot, but yeah, it's still in the, what's shown there is still showing the El Nino conditions, and we expect it's now moved towards the center of the index, around 0. Okay, and that's the last slide there. Thank you.
Thanks, Henry. We did have one question come in, and I think it was for Roxanne. And whether her question was, or the question was, were that HABs you mentioned, I think in the Oregon coast, unprecedented by their timing or by their level of harm?
If Jan is on the line, she would know better how to answer that question.
Yes.
Yeah. There you go.
And can you hear me? Can you hear me?
Yep,
Yes?
we can hear you,
No?
Jan.
Can you hear me?
Yes, we can hear you.
Sorry, I couldn't talk. All right, I answered it in the chat. And so it was unprecedented in terms of both the harm as well as the concentration of cells.
Great, thanks, Jan. And Clarissa, I think you have control now.
I do, but
There we
something
go.
happened again. Do you see? I don't think you're seeing the talk anymore, are you?
I'm seeing an Appendix C.
Yeah, nobody look at that. Highly sensitive material. I had it up 1 minute ago, and then it seemed like you had stopped me in order to take that question from Roxanne because it went away.
Oh no. If not, I do have your slides here. So
Yeah, why don't you just throw them up, because I'm
Okay.
not happening.
Sorry about that.
Happened a while ago too. I don't understand it sometimes. It looked like they were there. Everything looked great.
Just flipping through.
Huh. Okay.
Okay.
I think I'm seeing the slides that you're all seeing. I hope so.
Yep.
All right. So we're going to shift to Southern California, and as in the past, I'll present a bit on some of the SCCOOS data and pass it to Jim Behrens for some more CDIP wave data. We've got a little final slide too that we can finish on. So next slide, please. Yeah, so those opening pictures were of a pretty nice bioluminescent event that we had recently here in Southern California. It was really more like Newport down to the border, more or less. And we've reported on these dinoflagellate blooms in the past. They seem to be cropping up a lot in the spring now. They used to be more traditionally fall, late summer events. You know, we're used to seeing a lot of dinoflagellates come in around now, often at the tail end of a diatom bloom that has bloomed in response to an upwelling pulse. It's kind of a natural succession that we anticipate, but what's been hard is predicting which organism in that dinoflagellate assemblage is going to be the bloomer. While we did see a lot of bioluminescence, and there was another media frenzy over that, what's interesting is that was a fairly ephemeral event. A lot of the dinoflagellates that can cause that were in the water, but the one that's the most vibrant bioluminescent producer is Lingulodinium polyhedra. I have it circled here on the left panel from May 30th. And you're seeing an imaging flow cytobot time series in the lower left. This is using the image data that you see in the upper right, but then applying a machine learning algorithm to it to classify those various taxa. And what we get is this kind of a bar plot, or you certainly could visualize it many different ways. And L. polyhedra is in kind of a pink color, like I would say what are we going to call that? Like a fuchsia as opposed to a pink. And that one was around, it was around more in May. And then as we went into early June, we were still seeing quite a bit of bioluminescence coming in terms of reports, but the community was shifting quite a bit. And that's where that more of a pink color starts to dominate. And that's the organism I have circled on the right panel, which is a Kashiwa sanguinea. And this is the one that looks kind of like a tooth. It's been becoming more increasingly dominant in dinoflagellate blooms in California in recent years. It can be associated with bird deaths because it creates this kind of surfactant that gets on their feathers. They can't clean it off, and then they will perish from hypothermia. There's also a risk to things like desal because it can clog filters. So I'm pointing out that this is where we've been lately. There's been a lot of calls about this because even when the bloom shifted from the L. poly dominated bloom and bioluminescence was subsiding, the water was still very red-brown. People start to worry if that's pollution. They don't always know that it's kind of a natural phenomenon related to plankton. Next slide. This capture here is cracking me up because it looks like I'm about to strangle somebody, the reporter, I guess. So this is the kind of thing I was talking about, all this brown water, people are alarmed. The tagline here is actually not correct. I did not say that the red tide was not associated with bioluminescence. In fact, it was. It was just that at the time that we were doing this interview, things had shifted such that the dinoflagellates that were dominant were not the ones that produce bioluminescence. But we have been wondering, and we've been getting some inquiries from folks like Chris Lowe at Cal State Long Beach, who runs the shark lab there, about the interplay of this bloom with the white shark attack that was well publicized and discussed on national media that did happen around the same time. It happened at Del Mar. While Henry referenced that all these sharks are going north, we still have plenty down here in Southern California where they seem to have, many of them have moved in recent years. And it was a surprising event in that a swimmer was attacked by a fairly large, maybe 10-foot shark. And that happened with this red tide. And so it does look like turbidity was very high as a result of this tide. Visibility was very low. And it may very well just be some sort of identity accident because of the the lack of visibility and the fact that sharks can't see very well, and they're coming up from the bottom below some of these bloom layers. Next slide. So I'm going to shift into the El Nino discussion. We are moving into this ENSO neutral state, and I'd like to see what that looks like for our glider data and our shore station data. Next slide. Very similar to the plots Henry showed. We are now on a different line though. We're off of Dana Point, and you can see that in the nice map in the lower right. We're looking at different depths though, 10 meters and 50 meters, similar plot to what Henry showed on the left, which is that anomaly of temperature on top of the oceanic Nino index. Often tightly coupled. We see this at all the lines, which is really fascinating. You saw that in lines further north in Henry's slides. But at different depths, we see different kinds of coupling. It's pretty tight at the 10-meter layer, a little less tightly coupled at 50 meters, as you can see in that lower plot on the left, where the warming starts to decrease a little bit before we start to see that change at the equator. And so these are interesting questions for the physical oceanography group to understand how heat content and heat in our region is or is not connected to what's happening at the equator and what drives those differences. In the Huffmuller diagrams on the right, where we're looking at that time frame, there's been a lot of heating in the Southern California bight. It's pretty evident that that turned on around the warm anomaly and has continued, but there's punctuated by upwelling events. If you look at the 50-meter plot on the right, you're seeing some of the cold water pushing up onto the shelf. And that's where our shore station data become useful, because we can look at these upwelling pulses that are happening within kind of a backdrop of some steady warm anomalies that are happening overall. But there's a lot of local, even hyperlocal dynamics that change what that looks like for the organisms in the water. Next slide. So these are the shore stations for Southern California, and we've shown you these before, so you're probably well acquainted, and you saw this in Henry's talk, that these are the temperature anomalies. So those blue bars throughout the spring are really indicative of the kind of strong upwelling that we have that's quite seasonal and expected. Starting to get a little bit of warming at places like Stearns Wharf and Newport Beach Pier, right in the most recent part of this time series, and then Santa Monica Pier and Scripps Pier, pretty consistent cooling at those stations, upwelling induced. Explains a lot of the blooms we have had. You know, I didn't get into the fact that we had some domoic acid fits and starts this spring, mostly around the Santa Barbara Channel Islands, but some stranding events at the Pacific Marine Mammal Center down in Laguna, which seem to be connected with domoic acid, but it has not really reached that kind of fever pitch like it has in recent years. So we didn't really show those plots, but this is the kind of seasonal upwelling we expect, and it's going to drive local productivity. But interestingly, the cutie and beauty plots that Henry showed, if you look at this latitude, you don't see the concomitant increase in things like beauty, which is that biologically effective upwelling, the nitrate that's in the water that can produce a bloom and stimulate a bloom. So it's not clear if those indices are just not working well in our region, or if it's just that we're kind of in standard normal in terms of how much nutrient content is in those upwelled waters. I would expect there to be a reduction in that in some level due to the El Nino we were in, but it did kind of subside in a way maybe earlier in the winter than we've seen in some of the others. It's just very, very hard to say. And the marine mammal community is certainly interested in understanding how these elevated sea surface temperatures within the region are contributing to things like that, the pup starvation or the death of those pups and those pelicans, and what it means for forage fish like anchovy who feed at different depths, and if they're too deep due to some kind of physical phenomenon or other biological interactions, then we might not have, those animals might not be able to access them. Okay, next slide. I think this is where I shifted over to Jim. Oh no, that's right. We added something on the oxygen and pH this time. We haven't been showing these data too much, but we do have some sensors at various piers. And I'm really gonna just quickly say that if you look at this time series where we're looking at dissolved oxygen, saturation, and pH, there are some significant upward blips in the last month, which I think are connected to the some large blooms that we've been having up against the coast and that's pushing oxygen up. So more on that to come. Next slide. I'll push it over to Jim.
Thank you, Clarissa. Just a brief update from the CDIP program, the West Coast Wave Activity. As you can see with our Point Reyes station that's been around for quite a while, we are riding the climatological expectation pretty much recently. And the sea surface temperatures, they're starting to warm up a bit, and this station here, San Pedro South, has been sort of clinging to the cooler temperatures, but even that one's starting to return to normal. This one's a little bit further off of the San Pedro shelf as part of our collaboration with the Marine Exchange of Southern California. Next slide, please. And here's just to point out some of the news about the new stations that have been going in along the West Coast. The two stations that we were anticipating with NREL at PacWave off of Newport were deployed in April. These are reference gauges of energy converter testbed site, and there are other types of wave gauges all deployed in a pretty tight formation that you can see on the chart image in the middle over there. All those dots in between our two buoys are other sensors that are in the water there. So there's quite a bit happening there at that station. And at 70 meters, this is actually a good experiment for seeing how repeatable a data well wave rider is. Get two measurements in the same expected climate. At Pajaro Beach, we continue to maintain those stations, and we extended this co-location for at least another 2 winters because we've been seeing some interesting variation actually along shore in between these stations that are very closely spaced. They're less than a kilometer apart, but over there, this is on the top that you can see this HS map, the swell height entering Monterey Bay area, and all of the detail along shore variation that occurs. And so we have these stations going, and we have 2 more stations that are proposed and anticipated to be installed in the Monterey Bay region this year as well. So there you go. There's a little update from CDIP. Thanks.
And there's one more slide. Yeah, Henry, we can't let Henry outdo us with photos, so we added a few more. This is that event that Henry mentioned, and it was a Cal Coffee SCCOOS joint event. Really, really fun. Here's some numbers that give you a sense of how many people were there, and some really lovely pictures. Would be remiss if I didn't point out in the lower left that these are the 4 women who made it happen, and it was. We're hoping to do it again sometime, and I know many of you people on the call were there and represented the ocean observing community in California. We were sad Jan couldn't be there to represent NANOOS, but yeah, it was a fantastic meeting. So, and I'm seeing some questions. I might try to help with the AR one. I don't know how many atmospheric rivers have hit the West Coast in that time period. We haven't had as many as we did the year before, even though, you know, there's often a somewhat of a statistical correlation between precipitation and El Nino. It does tend to break down. The better correlation is between drought and El Nino, but we've seen some, and in fact, when we had a big El Nino press event, it happened to be the day after a massive AR hit down here and caused a lot of flooding, but that AR was not necessarily because we were in an El Nino year, but I think that's hard for us to say specifically, and anyone else can jump in and answer that question too. And thanks for showing my slides, Joe.
No problem. Thanks, Clarissa, and thanks, Roxanne and Jan and Henry for another great week. Kyle, I'll actually also send you a link to CW3E's website, the Climate, Weather, and Water Extremes out of Scripps. They do a really nice job of cataloging the AR events, and so you can take a look, and they have their own index where they not only, the index that places them by magnitude, but they've also gotten some new ones that kind of show the direction and the windrows approach. And so that's some neat stuff that they are hosting. We have 2 minutes left. Let me just check and see if there's any more questions. Looks like Mike Anderson. We actually had more ARs this year than 2023. They were just weaker for the most part. Yeah, so maybe not some of the big ones that from the previous winter. Great. Well, thanks everybody for your attention, and we will look forward to seeing you at next month's West Watch. Take care. Thank you.
Thanks, Joe.
Thanks, everyone.